Since this is linear algebra, we're going to talk about linear equations in two variables. We know it as ax plus by equals c in regular algebra. In linear algebra, yeah, we can use that, but because we're in an upper level class, this is a sub 1x plus a sub 2y equals b, where a1, a2, and b are constants. Or you may see it as a sub 1 x sub 1 plus a sub 2 x sub 2 equals b. In that case, a sub 1 and a sub 2 and b are still constants. It's just that x sub 1 and x sub 2 take the place of a regular x and a regular y. Not only do you have linear equations in two variables, but you have them in three variables. In three variables, the usual format is ax plus by plus cz equals d. In some classes you may see it in upper level maths. A sub 1x plus a sub 2y plus a sub 3z equals b. And again, a1, a2, a3, and b are constants. And I'll say it again. You may end up seeing something like a sub 1 x sub 1 plus a sub 2 x sub 2 plus a sub 3 x sub 3 equals b. Again, all of these would be the same. These would be constants. x1, x2, x3 replace x, y, z. For chapter 1, we are going to concentrate on this setup of linear equations in two variables. So this is going to be really important, and this is going to help us out in chapter 2 and chapter 3, and so on. So we want to get used to it first and understand why before we start getting into matrices. Can you have more than three variables? Yes, you can have more than three variables in a linear equation. So what we have is a linear equation in n variables. A sub 1 x sub 1 plus a sub 2 x sub 2 plus a sub 3 x sub 3 plus dot 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 plus a sub n x sub n equals b. This is where a1 through an are the coefficients, and they belong to the set of real numbers. They can be complex, but for our class they're mostly going to be real numbers, but they can be complex in upper level classes. B is going to be a constant term. X sub 1 is the leading variable, a sub 1 is the leading coefficient, and x1 through xn are the variables in the linear equation, and the subscript n may be a positive integer. We're now going to talk about system of equations. We can talk about a 2 by 2, which are two equations with two unknown variables. We have a 3 by 3, which are three equations with three unknown variables. This is just what we call it for short. The first system that I'm going to talk about is a consistent system. There are two lines or three planes that are different. They have one intersection. In other words, the lines, if I'm in R2 space or 2D space, the lines cross once. They will have one solution, which is a point in R2, in 2D, and the notation for our answer will be x, y. Here's a visual of our problem. So we have line 1 and line 2. They cross at one point. That one point will be our answer. Our answer will be of the form x, y. So 1, 5, negative 3, 2, etc. So a consistent system crosses one time. It has one solution, and that solution is insert point there. Next system, we have an inconsistent system. This is when two lines or three planes are different but parallel. They have no intersection because they are parallel lines, and parallel lines don't cross. We will have no solution, and the notation for this is the following. You can use the empty set, or you could use, and I know this one looks like phi or phi, but I couldn't make one work for this program. So it's just a line through a little zero, but this line is very long. This is the null set. That's how we call it. What does it look like visually? Well, you have two parallel lines. They are parallel, but they have different y-intercepts in R2. This is what we call parallel in this case. Since they never intersect, there is no solution, hence the reason why the notation is the null set or the empty set like this. So what I'm going to ask is, if they are parallel, what type of system is that? Inconsistent, that'll have no solution, and the notation is such. Next, we're going to talk about a dependent system of equations. There are two lines or three planes that are the same line. They have an infinite number of intersections because they overlap each other. They're on top of each other. They are the same line. We will have an infinite number of solutions. The notation when you have two lines is going to be the set, that's what those brackets mean, of points x, y, such that insert one of the original given equations here. It does not matter because they're both the same. Or in 3D space, when you have three lines, it'll be the set x, y, z, such that insert one of the original given equations here. What does this look like visually? You have two lines that are exactly the same, line 1 and line 2. This is a dependent system. It has an infinite number of solutions, and the notation is written like this. All system of linear equations must be in standard form before starting any work. For a 2x2, it must look like this for solving them, and for a 3x3, it must look like this for solving them. Also, when you want to solve a 2x2, you have two methods, a substitution method and an elimination method. When you solve a 3x3, you really want to use the elimination method because substitution will take a very long time. So anything about a 3x3 or above, you want to use the addition or elimination method. For a 2x2, you can use either or. It does not matter which one you use. But when I say use this method and you use this one, I will mark you wrong. So be very careful of the method that I specify on the exam. We're going to go over the substitution method for a 2x2. We have two equations with two unknown values. What I like to do when I'm giving a 2x2, I'm going to call this equation A and this one equation B. Let me go through the steps. Pick an equation, any equation, it does not matter which one, and determine which variable you want to solve for. I chose equation B and I want to solve for y. I'm just leaving my notes for me because I don't remember half the time. So here's equation B and I want to solve for y. The reason why I chose equation B is because there's a coefficient of 1 on it, and second of all, it is positive. So this makes it easier to solve. I don't have to manipulate this and then divide by a number. So example B, or problem B, is the easiest one to solve for. I am now going to solve for y, and here you go. Y equals x plus 3. That's step 1. I picked an equation and solved for a specific variable. The next thing that I want to do is put the variable I just found right here in step 1, and I'm going to put it into the other equation I didn't choose and solve for the variable. So whatever I chose, I solved for y from equation B. That means I'm going to take this answer here that I solved for and put it into the other equation, equation A. This is equation A that I did not use, and this is equation B in which I solved for y. I'm going to take this y and put it into here. Using substitution, I will end up with one variable in this problem. And then I'm going to solve for the variable. Now that you solve for the x value, that implies that you have to find the y value to this problem. Let's talk about step 3. Take the variable you just found, which is x equals 1, and you can plug it into either equation, equation A or equation B, to find the other remaining variable. So what I did was, and again, it does not matter which equation you choose, I chose the easiest one. So I chose equation B, and I'm going to let x equals 1 because that's what we found in step 2. And this will allow me to solve for the variable y. X equals 1, so that I got a negative 1 plus y equals 3. I'm going to solve for y. Y equals 4. I wish I could say that this is the end of this problem, and it's not, because on the exam I'm going to ask for one last step, which is to tell me what I've got. So here's what I want you to do on your homework when you do it. First thing is tell me the type of system. This is a consistent system because I got a y value and an x value. What does a consistent system mean? I have one solution. The reason I have one solution is because they crossed at one point, somewhere in space. In this case, they crossed where? At 1, 4. So the type of system is consistent. Number of solutions is 1. Don't give me 2 because a lot of students give me 2 because that's an x, that's a y. I got one solution. It is at one point at which they cross. What is that notation? It is the point 1, 4 for a consistent system. Let's talk about the addition or elimination method on a 2x2 system. So again, I gave you two equations. This is equation A, and this one I'm calling equation B. Step 1, I want you to pick a variable you want to eliminate, and then we're going to build up the equations and solve for the remaining variable. Here's what I mean. This is the addition method. So we're going to be adding these two together in such a way that I get rid of one of these variables. It is up to you to pick which variable that you want to do. Now, if I look at this problem, you can do this one of two ways. I did it a little bit in the harder direction, but if I were you guys, since the y's are opposite signs, I would choose to get rid of the y's. But I chose to get rid of the x's. That is not a big deal either, because of the fact that it's easy to... I chose in this case to get rid of the x's just to show you how to do this. So if I'm choosing to get rid of the x's, because that's what this is showing me, how do I get rid of the x's in such a way that these will become 0? Well, basically, I look at 3x and 2x, I see 3 and 2, I think of in my head something like an LCD. What do 3 and 2 go into? They go into 6. So I'm going to build up this 3 to a 6 and this 2 to a 6. Whichever one I want to multiply by a negative, that's totally up to you. I chose to take a negative 2 times equation A and 3 times equation B. I could have just as well taken 2 times equation A plus a negative 3 times equation B. But I'm going to do it this way. When you multiply equation A by a negative 2, you multiply the entire equation, both the left and right hand side, by the negative number. I took 3 times equation B, both the left and the right side. Every single term must be multiplied by this number. Once I do this, the whole idea is to drop out a variable. In this case, I chose to drop out an x. Negative 6 plus 6 is 0. Now that the x's went away, I have a y variable left. When I solve for y, I get y equals 2. This is your step 1. Step 2, you're going to plug in the variable you just solved for into either system and solve for the remaining variable. So you have y equals 2, you can plug it into equation A or equation B. I don't care. I chose y equals 2 to plug into equation A. Again, I could have easily chosen equation B. So I'm going to use substitution, and then I'm going to solve for x. There you go. I solved for x. Again, this would be nice if this is where I stopped at, but I'm not going to. I really need to concentrate on the names and what type of systems we got. So I got an x value and a y value. That tells me this system is consistent. Type of system, consistent. This is what I'm going to say on the exam. You will give me this. Number of solutions. We have one solution. We got an x value and a y value. That makes 1 point. What is that 1 point? the solution notation. All right, so that's where it comes in. This point comes in here. The solution notation is xy, better known as 3, 2. This is the point of intersection. This is the one point on which these two lines cross at. This is a consistent system. We're going to go over this problem. I've got x of 1 plus 2x of 2 equals 1, x of 1 plus 2x of 2 equals 2, and we want to do this 2 by 2 system by substitution. What I'm going to do is I'm going to call this equation A, and I'm going to call this equation B. Now, since this is substitution, I'm going to pick one of these to solve for. I don't really care which one. And I'm also going to solve for a variable. In this case, I'm going to solve for x of 1. So here I'm going to choose equation A, and I'm going to solve for x of 1. When I do that, I get x of 1 is equal to 1 minus 2x of 2. The second step that I'm going to do is I'm going to take x of 1 and I'm going to plug it into equation B. So I'm going to be using equation B where x of 1 is equal to 1 minus 2x of 2. So equation B is x of 1 plus 2x of 2 equals 2. And I'm going to use substitution for x of 1. I have 1 minus 2x of 2 plus 2x of 2 equals 2. Notice that everything now is in terms of one variable. That's the way it should be. Next, I'm going to get rid of my parentheses. 1 minus 2x of 2 plus 2x of 2 equals 2. Negative 2x of 2 plus 2x of 2 gives me 0. I get 1 equals 2. Notice that my variables dropped out. If your variables drop out, you've got one of two things going on. Either it's going to be true or it's going to be false. 1 does not equal 2. This is a false statement. What does this mean? If you've got a false statement, this implies an inconsistent system. All right, number of solutions is going to be none. All right, what is my solution notation? It's going to be the empty set. And if I was to ask you why is this happening, you would actually have to say they're parallel. These are parallel lines, they'll never cross. Therefore, this is an inconsistent system, no solutions. This is the null set, and you can use that one or you could use the empty set of brackets, it doesn't matter. But the reason why is because these two lines, A and B, are parallel. And you saw none of that. There you go. How's that? So one more time. What type of system? Inconsistent. How many solutions? There are none. Solution notation, pick one of those two, don't really care. Why is this so? These two lines are parallel. All right, we have a new example. We have 4x minus y equals 9, negative 8x plus 2y equals negative 18, and we want to solve this by substitution. One more time, I like denoting mine by equation A and equation B. I'm going to choose either equation. I'm going to choose equation A. I'm choosing equation A because there is a negative 1 in front, and it's a lot easier to deal with changing of a sign. And I'm going to solve for y. Okay, so that's the reason why I'm choosing equation A. There's a negative 1 here in front of the y. I'm going to solve for y. So what I have right now is 4x minus y equals 9. If I add the y and subtract the 9, I get y is equal to 4x minus 9. I solve for y. Step 2 is I'm going to plug this, because it's substitution, into the other equation. So I'm going to plug in into equation B, y equals 4x minus 9. Equation B is negative 8x plus 2y equals negative 18. And again, y equals 4x minus 9. I'm going to put it right in here for y. So when I distribute, I get negative 8x plus, you know what, I won't distribute first, I'll just plug it in for substitution. 4x minus 9 equals negative 18. I'm now going to distribute the 2. Negative 8x plus 8x minus 18 equals negative 18. I have like terms on the left. Negative 8x plus 8x is 0. I get negative 18 equals negative 18. Or you also could have given me 0 equals 0. A lot of ways to write it, but no matter what, notice that both sides are equal. Cool. What does that tell me about this problem? This should be step 3, not step 4. So, what type of system is this? This is a dependent system. I can spell it, honest. Dependent system. Number of solutions is infinite. You can write it like that. I know a lot of you write it like that. So if you, whichever one you want to use is fine. And the solution notation is going to be the set of points x, y, because we are in 2D, because we only have a x and a y variable, such that put either equation here. It does not matter. So if you want to put in the first one, it's a little bit easier to write. 4x minus y equals 9, and you are done with this problem. And this is by the substitution method. All right, next we're going to be solving 3 by 3 linear equations. Now the easiest way to do these is the elimination or addition method. They're the same verbiage, naming the same thing. So here is my problem right here. I gave you 3 equations with 3 unknowns, x, y, z. I labeled them A, B, and C to help me figure these out, so I know who I'm talking about. So let me give you the directions first for step 1. I want to go from this 3 by 3 to a 2 by 2. How do we do that? Pick a variable you want to get rid of, and I'm going to pick z because z has a coefficient of 1. Alright, so that's what I want to do. I'm going to get rid of z. The second thing I'm going to do is pick 2 pairs of different equations. You can't pick the same one. So I'm going to go from a 3 by 3 to 2 2 by 2s. I can do AB, AC, or BC. Those are the only choices I have. So the easiest one for me to see and also to get rid of z is to do the B and C because they're opposite signs. Hence the reason why I chose B plus C. And hence the reason why I'm going to get rid of z. Now, if I tell myself that I'm going to get rid of z, I have to get rid of z in another pair. So, how do I do that? Well, this is a positive 6, and this is a negative 2, well, this is a positive 6, and this is a negative z, negative 1z. These are opposite signs. Again, I cannot choose B and C again. So I'm going to choose A and B because of opposite signs, just like B and C were opposite signs. But what I'm going to do is not only going to choose equation A and B, I'm going to choose 6 times equation B to get rid of this z variable. So if I do B plus C, I'm simply going to add them together. I'm not going to do anything weird. This is my equation A, but then I multiplied 6 times equation B. This will help me get rid of the z over here, and the z's will automatically disappear on this side on B plus C. I now have a new equation in 2 variables I'm going to call P. And again, I have this new equation in 2 variables, and notice they're the same variables, and I'm going to call this guy equation Q. I'm trying to keep it in the middle of the alphabet because of the fact that I chose A, B, and C there, and I want to make a clear distinction between this and the original problems, which are A, B, C. That's the only reason why. Step 2. What I'm going to do is pick a variable to eliminate from the new equations P and Q. and solve for the remaining variable. So this is like starting a 2x2 problem all over again. So what am I going to do? Good question. I have no idea what's below here. Let's take a look. I did negative 5p plus q. Okay, that makes sense. Then what that means is by taking a negative 5 times p, negative 5 times p will get rid of the x's for me. So it looks like I'm getting rid of the x's by doing this 2 by 2. So negative 5 times p means I'm going to take negative 5 times all of p, every single term, both left and right, multiplied by 5. And I'm going to add it to q. And it looks like the x's go away. And I am left with 5y equals negative 5, meaning y equals negative 1. I got a number. This means I'm going to get a consistent system automatically the moment I solve for a variable, whether it's x, y, or z. This is where I'm going to shorten it up a bit because I'm running out of paper. Plug in the variable you just found into p or q. So y equals 1, negative 1, I'm going to plug into either p or q, it does not matter. So this was 3x plus 2y equals 4. This is the p equation where y equals negative 1. I plugged in negative 1 for my y value, and I solved for x. And 3x is equal to 4 plus 2. 3x equals 6, divide by 3, x equals 2. So now I have an x value and a y value. Great. Step 4. Now in step 4, I'm going to plug in the 2 that I found, and I'm going to plug it into one of the original equations that I have, a, b, or c. So x equals 2 and y equals 1, and I'm going to plug it into, I have no idea, x plus y plus z equals 2. I plugged it into equation C. So x we said was 2, y we said was negative 1. So x and y get replaced by their respective numbers, which means I'm going to solve for z, and z equals 1. Again, this is not the end of the problem. I'm going to have you do an extra step. What type of problem is this? What type of system is this? This is a consistent system because I've got values for x, y, z. We have one solution because we can form one point. What is that solution notation? That solution notation is the point 2, negative 1, 1. So I do want this on your homework. I've been looking for it for 1.1. Now when you're doing the 3 by 3s, and this is the same problem that I just got done doing. When you do the 3 by 3s and you're looking for a dependent system and an inconsistent system, it's going to fall out real rapidly. The longest problems that you're going to find are the consistent problems. So if I have a dependent or an inconsistent system, the steps fall dramatically. And it just follows the same thing as a 2 by 2. All right, we are going to be learning about the substitute. No, we're not. We're not going to be learning it. We're going to review it. I also could have gotten rid of the x's. This is a little bit more involved, but not, no, it's not. It's not even involved whatsoever. What are you saying?